A function in Python is an object. We can have an attribute that holds a reference for a specific object that represents a specific function. When we define a class, we can include in the definition for our class a definition for a function or functions. When doing so, for each and every function, an object will be instantiated in order to represent that function, and the object that represents the class, a new attribute will be added to that object, and that attribute will hold the reference for the object that represents the function that we define. So for instance, if I define the function area in my definition for the class rectangle, and over here I specify that whenever area is invoked, I want the code return self.width multiplied by self.height to be executed. It means that whenever I call this specific function, the first parameter will be assigned with the reference for the object on which this specific function is invoked when we invoke that function on a specific object that was instantiated from the class rectangle. So if we complete the definition and include the definition for the magic function init, and then if I instantiate rectangle and then I invoke the method area on the new object, we can expect having 20 printed to the screen. When we invoke the method area using this syntax, and we could of course specify a separated variable to which the result will be assigned, calling the area function by specifying a specific object on which we want to invoke that function means that indirectly the compiler takes this line and switch it with another line that looks the following: result assigned with rectangle dot area, and the value of OB is passed over to the method area. So the output is actually exactly the same. Whenever you invoke that method should take as the first argument the reference for the object on which that method should be invoked. So you can either do it this way or you can do it this way and then expect the compiler to change the code into this version. It is actually exactly the same. A method you define in a class, when you define a class in Python, is actually an object that its reference is stored in an attribute that its name is the name of that function, and that attribute is actually an attribute that belongs to the object that represents the class. In some cases, we might be interested in defining a class that includes functions we shall use as utilities. As in this code sample over here, we define the class utils. It includes one function, calculate tax. Calling that function, passing over the income, we get the tax that we need to pay. So if, for instance, we pass over the value 100, we can expect having 40 printed to the screen. Just as with defining the function area, the function calculate tax is actually an object that its reference is stored in attribute. The attribute belongs to the object that represents the class, just as in the previous sample when we defined the class rectangle. So over here we refer the attribute calculate tax and we pass over the number we want income to be assigned with. Now if we want, we can add the static method decorator. Doing so won't change anything when this is the code. The output will be the same. However, if we decide that we want to write ugly code in which a variable, its name utils, is assigned with the reference for an object instantiated from a class utils, and then we want to invoke calculate tax using that object, adding the static method decorator means that we can expect income to be assigned with 100 and the output would be the same. However, if we don't specify the static method decorator, then calculate tax is actually exactly as the method area or any other method we define in rectangle in order to allow its invocation on a specific object that represents rectangle, meaning that unless we add another parameter, and we usually call that parameter self, this code won't be executed as expected. If we add the self parameter, it shall work properly, but without it, it won't. As you can see, it won't work because calling calculate tax on a specific object that was instantiated from the class utils and having calculate tax defined as a simple method, not a static one, meaning not mentioning the static method decorator, means that over here income is actually assigned with the reference for the object that was instantiated from utils. So bottom line, it would always be better if we specify static method, the static method decorator, whenever we define a function we want to use as a static method. Class method decorator allows us to specify a method we define in a class, a method we want to use as a utility, and have the first parameter automatically assigned with the reference for the object that represents the class we're dealing with. So over here, if we specify that calculate tax is a class method by adding the class method decorator, it means that CLS will be assigned with the reference for the class utils, the reference for the object that represents the class utils. We can still write ugly code as this one. As you can see, it works fine. However, we're not interested in this ugly code. This is something we better avoid. So let's add the comment character and let's change it into utils with capital U, because we want to invoke calculate tax as a utility that belongs to the class utils. Now, having CLS assigned with the reference for the object that represents the class means that if, for instance, we have a variable, or let's say an attribute we add to the object that represents the class utils. We can over here, instead of writing O.4, just specify cls.tax, and it should work fine. So this is the difference between the static method decorator and the class method decorator. This is the only difference.